if you recall, this is where we are. We are kind of this week, right? So this is where we are. Now, the way I originally planned, again, having given you guys the background, okay, a bit of probability, statistic, and mathematical background as well, and the main paradigm of supervised learning and unsupervised learning. Okay? This thing we haven't covered yet. We'll come back to. But basically, we kind of ready to get the project started. Okay, we're ready to get the project started, and we're using the project as a vehicle for learning. Yeah, so hopefully, and it really is a bit of a hit and miss, but hopefully that there'll be enough variety in the choice of projects that you guys choose that we can cover a lot of things. In other words, it would be kind of uninteresting if all your projects are based on, let's say, time series prediction. Again, everybody will be doing the same thing. That's not really the objective of the exercise. Really wanted to see a little bit of supervised learning, quite a bit of supervised learning, obviously, maybe closely followed by unsupervised learning, and maybe some other variation of data analytics that does not use a lot of machine learning. So, for example, maybe a lot of visualization, a lot of probability statistics, and so forth, right? Also, then I'll be coming back periodically to give you more lecture on more advanced topics here and there. I'm having a little bit second thought on the lecture 13, which is about reinforcement learning and generative models. I think it's very useful for things like robotics control, okay, things like that. But for data analytics, it's still quite a way off. It's quite a way off. So what I might do is just this lecture 13, I might kind of like use that to as our spare either project or review or material coverage. Okay, so that's the only thing that might be changing. The date obviously will change quite a bit because we've had to move some dates. Okay, so that's it. That's for housekeeping. Right. Okay. Now, okay, I have this slide. I thought I would like to share with you, and the idea is that before we go to the project discussion, your TA pointed out that maybe you don't quite appreciate the whole picture of what it is we are doing, especially in terms of the data pipeline. So there's this picture that I want to give you. I use it quite a lot, so it appears in a lot of my other lectures. So I'll just pick it randomly. So this is another talk that I'm giving to another university. There was a talk earlier about relating what we are doing here with bioinformatics and computational biology. But anyway, the slide that I want to bring up to your attention is this thing. Okay, it's this little slide. Let's backtrack, from the very beginning. There are certain terms that are being thrown at you as a modern technology that you need to know. Words like artificial intelligence, machine learning, quantitative models, and data analytics. And this is how they relate to one another. Okay, you can say that artificial intelligence, or what happened in artificial intelligence beginning in the 1950s, sort of like motivates or inspires a lot of the machine learning paradigm. Okay, so machine learning, the algorithm that we are learning today and being developed, a lot of them, not all of them, but let's just say 80% of the machine learning paradigm came as a result of our trying to understand what makes a human intelligence by trying to mimic it with computer system. Okay, so by trying to get the machine to learn and act like a human being, we try to mimic the process of human learning, and that's inspires a lot of machine learning algorithms. Now, machine learning algorithm in itself can be used to try to create an artificial life, an artificial chatbot that resembles a human being in certain behavior. But in particular, one of the most important result of the machine learning research is the ability to build quantitative models. Okay? Ability to build quantitative models with very little mathematical or statistical assumption. Okay? Now, I would like you to look at, I haven't made this slide, but maybe I'll make it at home some point. Not all quantitative models is built by machine learning. If you look at your first year syllabus, your first year class, you have statisticals, inference, probability and statistical tools. Those also build quantitative models. Okay. You also have things like optimization tools you might learn in operations research, like linear programming, quadratic programming, dynamic programming. Those are also part of what builds quantitative models. But I would say again that the dominating player, just like most of machine learning is inspired by artificial intelligence, I would say that most of the quantitative models that we will be using in the next 5-10 years, a lot of them will be derived increasingly from machine learning. Okay? And quantitative models of any kind is what drives the data analytics. Okay? So to bring the whole thing full circle, data analytics in turn validates whether or not the whole research we started in the 1950s, artificial intelligence and whatnot, has been worthwhile in terms of utility. Okay? But again, bear in mind that people who started artificial intelligence research did not have data analytics in mind. Okay? So this loop is sort of like very focused on this class. The focus on this class is to land somewhere with data analytics. Okay? But as the diagram I wrote on the board and it's being shared in the line group, there are other aspects. There are other things that help build quantitative models that's not based on machine learning. But because this is the predominant theme, by focusing on data analytics, we would be focusing automatically a lot on machine learning, which is why we spend quite a bit of time on supervised learning and unsupervised learning. Okay, so I want you to understand this kind of setup, this kind of background of where we came from and where we're going. Now, the things about using machine learning in data analytics is that unlike things like statistics, where you kind of know that once you get the data, you kind of do certain thing, right? You do a statistical test, you do the fitting, blah, blah, blah. This is kind of procedural. Well, machine learning based data analytics also has its own kind of procedure. And that procedure is sometimes what we call data analytics pipeline. Okay? Pipeline meaning something that starts from the beginning. Okay? Think of a plumbing. Think of a plumbing in your house. You have water coming in, right? And then you have a pipe that goes to your bathroom, goes to your kitchen, and blah, 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 and goes to the sink, goes to the shower, goes to the toilet. It's that kind of connection from beginning to end. It's a flow, it's a workflow process. That's what data scientists mean by pipeline. Okay? This is what the second part of the class, which is began right last lecture and continuing on, is all about, is for you to learn the pipeline, how to build the pipeline to do data analysis with mostly machine learning. Okay, again, when I say with machine learning, I would say something like 80% of the data analytics going forward would be based on some kind of machine learning tools. Okay, but of course, if you're doing something very specialized, you can do data analytics on the human genome, for example. A lot of it is not based on machine learning. A lot of it is based on the science of genomics. Okay, but as in the lecture that I presented last week to another university, there's a room for data science to come and help there as well. Hold on. answer this right now. Right. Sorry, discipline. Okay. So what do I mean by data science pipeline? Okay. Data science pipeline means you start from data and you end with insight. And that's what we talked about from the very beginning, right? The whole thing about this class is to turn data into information, information into insight, insight to better decision making, and so forth, right? So it's a linear process in the sense that you can say that A comes before B, B comes before C, C comes before D. But it's not a linear in the sense that you only go one way. Sometimes you go back. And this happens a lot based on, you want to do something, you get the data, it turns out the data doesn't allow you to do that. So you actually go back to reformulate your problem. That is very normal kind of thing, okay? So let's think about data pipeline. And I just want to give you a few words so that you think about it when you start to plan your activities on the project, okay? So what's the first thing you have? Well, obviously, you have to have some kind of problem that you're trying to solve, or some kind of inspiration, some kind of issue that you want to tackle, right? So this would be something like the problem area, okay? So you have to kind of define, I would like to use the board, but I think, can we go do that? Or do I have to use, okay, let's do this. I don't know if this is good, but let's try that. Okay. I have to go to share, right? New share, and I have to go to painting. Okay, is that right? Is something we do? Okay, so if you think about it, you kind of like have some kind of problem. Yeah, this is kind of your problem area. Oops. I'm really terrible with this, sorry. Draw shape, right? Where is it? Shape. Brush shape. Yeah. So this is kind of your area. This is some kind of problem, okay? Something you want to do, okay? But somehow the pipeline doesn't look like that. The pipeline starts with something that flows, okay? Now think of this, think of it this way. You have water, right? And in a household, the pipeline is not very pretty because it starts with clean water, ends up with dirty water, okay? But it's that kind of thing. You have a flow of something, and that gets manipulated over time, okay, over the course. So let's say you start over here with data, okay, data, right? And this data then goes to data, right? So this is kind of raw, right? Now, here, from raw data, you have to get to this point, which is kind of like some people like to say clean data, but it's a bit more than cleaning. It's everything, it's prepared. So it's sort of like, I would say prepared data. Oops. Prep data, okay? So that's data that's ready to be used, okay? That's data that's ready to be used. Now, if this were to continue to say statistical analysis, say something like this. Let's say what you want to do is statistics. Okay? And your prep data, okay, is in this form of picture. Okay? That's not good enough, right? In fact, sometimes statistics just doesn't do it at all. It deals with numerical data. So if you have something like category data, like boy or girlness, you have to turn it into Boolean, into boy is equal to 1, girl is equal to 0, or so forth, right? Before you go to statistics. But because what we're doing is machine learning, it's not statistics. Oops. I really prefer to use a Blackboard, but okay. Machine learning based analytics tools. Okay, this means that the data that you are going to use is a bigger class. It's a larger class. It's something that can be picture. It can be okay. It's more general. Okay. Do I really have to use this thing? It's taking me forever, but okay. But anyway, I'll try. Let's bear with me. I'm not you know, I'm not gonna use it. Right. So this is kind of your methodology here. Okay. Methodology. Okay. Based on that methodology, then you go to some kind of experimentation. Okay. Experimentation. Some data based on your data. And this is what makes it the heart of data science, because you can't just sort of like make up anything. And then you get some kind of observation, drawn conclusion. Okay. And that's the pipeline. Okay. Something like that, right? Now, roughly speaking, and then you have the final bit, which is maybe presentation and so forth. Okay. So this thing is about, it limits everything you do. In other words, you cannot introduce any more insight than there is in the data. Okay, so everything that's here has to come from there. That's what we mean by a pipeline. There's nothing introduced as a sideline. There isn't something like a human intuition added. Okay, if you're going to add that, you have to put it as part of your methodology. But basically, everything is based on data. Okay, you prep the data because some data is not representative. Sometimes you have to do some kind of cleaning. Sometimes you have to do all kinds of transformation. And this is the tool. This is the tool building part. This is the tool building part. This is the application of the tools, okay, where you actually apply and you get some results, and then you analyze what happened. And this is basically what you hope to be doing at the end of the project. Cái này cả? Hả? อ๋อ หนูไม่ได้เรียนคลาสนี้ งง Okay, so right. Okay, so last week we were talking basically this bracket here, this kind of idea here. And so some of you started to talk about this, which is I think the group that has to do with gold mining or something, sorry, predicting price of gold. And then we're talking to you about how about some kind of Facebook comments. So that becomes a source of data, right? And that's just harvesting. You're not preparing anything yet. You're not transforming. You're not doing anything yet. You're not learning anything yet. You're not building any kind of tools to predict, right? And when you build that, you have to run your experiments, like with different validation and so forth. So all these 5 steps will be there before you get to here. Now, while I have this page, which I'm going to throw away because it doesn't look that pretty, realize that the value of the project learning is not about what's drawn here. So I don't really want you to come up with a project that is trivial, but you end up with something that has like very good prediction accuracy or something like that. You know, if you end up with something very good here, like you have a very good model for predicting A to B, but it's something that's trivial, that's not worth learning, that's not teaching you anything. It's not a very good project. Okay, so basically it's the 5 step here that I want you to learn. Okay, it's the 5 step here. Now I should draw another one. Okay, if this is the problem, if this is the bracket called problem, there is another bracket that I should write as well called problem formulation. Okay, it's kind of like here. It's your X and the mathematical function or the tools that you're going to apply your X to. Okay, so this prep data is to merge your data into your methodology. But the idea that you want to do something, you want to do some kind of problem here based on this, that's basically your problem formulation. Okay, and this is how you end up with things that would look like supervised learning project, looks like a visualization project, looks like optimization tools and so forth. So I'm not making the annotations. Maybe I should. So this is kind of problem area, domain, application, and this here would be something like problem formulation. Okay, so maybe I'll draw that a little bit better. But your TA pointed out that you don't seem to get the right picture as to the flow here. So that's why I haven't drawn this thing up, but he mentioned it this morning, so I thought I would give it to you guys. Okay, so this is the flow that you want to go to. Now most of you were kind of here, and some of you started to talk about here. So let's think about that. Okay, I'm not going to save this because it looks terrible. Now I want to then leave the floor to the teams that did not have a go last class. Okay, so the way it's going to work is like this. I'm going to pretend I'm the head of your project. Okay, I'm the head of your project, or maybe I'm the principal data scientist, and you are your own team. You're responsible for some problem. Okay, and you actually went to contact the clients, and the clients came to you, and you discussed this project prospect, and you come to me. And let's say I'm approving this project. Okay, let's do this, and it's worthwhile. And what is your approach? Okay, I do a lot of back and forth like this with my own team. Okay, so imagine each one of you will be a team. Now the difference is that in real life, in a bank or whatever, you know, where I work, if I have 3 different projects, I would meet with one team, and most of the time the other team would just go and do their things. Okay, because it's not an educational process, right? It's a work process. So if I work on this project with this team, I just have the meeting with that team. The difference here is that if I'm having a meeting or discussion with team A, team B, C, and D should listen in. Okay, so it's a little bit like, you know, in a university hospital where when you're treating somebody, students are watching. Okay, it's that kind of thing, right? So I don't want your team to discuss your thing while the other team is on the floor. Right? You see what I mean? Yeah. You can actually jump in and take part. Okay. Even though it's not your project, you can pretend that for that period you are part of the project, or you sort of like a second or third tier member of the project that maybe have an idea or something like that. You know, you see, oh, how come you're not doing this? Or why are you doing this? Blah blah blah. Just raise your question. Okay. Now, which team wants to go first? I would prefer to not be the last class team. Okay, go. Would you guys like to come forward? Maybe sit here so we can work. You and me work. Whoa. Okay, fine. I get that, but you can get it. Okay. pay attention to your own team. Just pay attention to this team. Yeah. What have we got? Now, depending on who is going. Can you share your thing? Okay, excellent. Suicide rate overview. Okay, so it's predicting the rate, yes, of what is the population, what's the, and this is what? Suicide rate by year and country, right? So this big question. You want to do for over or in country or Thailand or okay. But what you do is for many countries. But okay. What kind of granularity, meaning what kind of prediction do they make? Do they say on suicide rate for country A in 2031? Is that it? Just 1 year suicide rate, or are they actually predicting a year-on-year increase, monthly increase? The suicide rate is an annual number. So first thing you want to see, okay. You guys remember the terrible picture that I drew? Yeah, from the data preparation. Well, each one of these has its own individual step in there. Yeah. So the data preparation itself, it has many things. First of all, you have to look at how much data you have. In real life, you have more about storage. This time, you probably don't have to. It's not really a big problem. So maybe what I might do is kind of like a checklist or something like that later. But basically, you have to look at the data. What do you do first before you do anything? Once you get the data, well, you have to load it up, right? Make sure the machine can read it. Okay? So that means all the invalid data has to be cleaned. Now, let's say you're working from presumably a well-curated data, right? Right? So there's not going to be any problem. You don't have to gather data yourself from some kind of database, right? So that is one big step right there that you don't have to do. For example, you don't have to go to a database of the National Institute of Health, download their internal database, and then create a kind of time series of that database, right? You have something to prepare for. Yeah? So it's as if the second step is done. It's not quite done yet. Because even though it's prepared, it's not necessarily prepared in the form that you can find it in your model. Yeah? So for example, if you picture what you have to do is something that we can teach them. In this case, okay, so you think of this thing, right? Master.ph.D. Is that what you're looking at? Did you look at it? No, you have to have looked at it. Okay? What does it look like? What kind of key do they give you? Open it up. Open it. Yeah. The fact that it comes in a CSV tells you one thing. It's a tabular data. Sure. I'm betting my life. I'm betting on it. Yeah? It looks like a master.csv. So double click that. So it's going to be tabular data, which means it's going to have items along the row and different fields on the column. So we need to know what kind of column does it have. If it's a time series, then it has nothing. It just has date value, right? But maybe it has what? Okay, let's see. Okay, open it in Excel or open it in Python, Pandas, if you like. Okay. Okay, fine. So let's go to all the way to the left and go one at a time. This is what I would do. This is what I would do. Okay. So it has actually countries, year, value. Now notice here, it has a lot of same value for the country, right? It has Albania. This is very typical of compiled international data. If you look at COVID data, if you look at, FAO, Food and Agricultural Organization data, if you look at cross-country data, they will tend to have something like this. Countries, you have a lot of entries with the same country, then you go to the next one and say, oh, here, right? There's a lot of Albania, sorry, Albania in 1987. So my guess is somewhere down the line that we need Albania 1988, Albania 1989, somewhere down the line that we Thailand 1988, or maybe Thailand has earlier record, or maybe that we Thailand 1983. Okay. If you want to focus on individual country, say Thailand or here, what do you have to do? Let me answer another question. You guys have Python, right? Pandas. What is the panda function? You guys learned about food fight in pandas? Oh, that's so good. You study Python for what? How long? Two classes. What 15 sessions, right? Did you cover NumPy? Pandas, P-A-N-D-A-S. And you said my PA or curriculum. Okay, Pandas is Python's way of dealing with tabular data. Obviously. Yeah, obviously. With tabular data, let's say you imagine you open this in Excel, right? What happens if you want to deal with Albania only? Okay? You would sort by country, right? And then you would highlight all the Albanians, right? And you find out that the top 200 rows is Albania. You want to take average. You take average, just the top 200 rows, right? Well, if you have Albania, you also have Algeria. If you want to do the same thing, you have to go to Algeria, right? And Algeria is row 201, 255. You want to take average Algeria or something, you have to average that, right? Well, this is a very funky way of doing things. And in order for you to do anything in Excel, you have to highlight, right? Right? You have to highlight, right? But if you have pandas, you can say, I want to find an average by country. Okay, something like that. So in pandas, it will give you mathematical likewise, all kind of visual programming. What it's going to give you is going to say, okay, I want you to group by country. Then for each country, I want you to do something like an average. Now, you don't want to group just by country, you want to group by country and by year. You do that as well. Group by country, Algeria, and 1987 to 1989. Alright? And then average suicide monthly rate, something like that. Okay? You don't have to highlight. Okay?
The point is, think about it. Imagine everything you want to do in Excel, you have to highlight, right? You have to have the beginning and the end and so forth, right? Right? Well, it's okay if you have hundreds of rows, but if you have millions of rows, it's going to be able to do that. So first of all, once you get to a certain size, Excel is add. Well, with pandas or mathematics, all kinds of programming, they read the whole file with very large capacity and allows you to do this. Okay? So if you wanted to do 5 times 3, that's what you have to do. So go back to your Python node and see if there's a pandas somewhere in your. Make sure you haven't seen it, or can you take it Python right now? So maybe it's in quick. I don't know, but it certainly you really can't just Python is a raw code. That's one thing. Yeah, it's a very good thing. Looks like this. Python just allows you to have a computer to do things. But to do things in the way that we tend to do things, that means like a first layer of life. First thing we like to do is handle pandas layer. That's where pandas. Second thing we like to do is multiplication by a lot of numbers, vector multiplication. So handling matrix vector. That's where NumPy. Do also mathematical concepts. That's where NumPy. Okay? What else do we do? We like to plot stuff. That's where math multiplication comes in. So, aside from learning the very basic syntax of Python, the second layer you need to learn are 3 things, a different things, right? Pandas, NumPy, and matplotlib. Once you get to this layer, then you get to the higher layer of libraries that people build to do things like machine learning, okay? Like analyze graphs, like drawing pictures, like segmentation of words, words. So this is library on top of this. Okay, so when you learn Python, you learn 3 layers. Okay, the basic layer, the hello world kind of thing, right? That's what we like this. And then the Python library, the main library, NumPy, group by, pandas, where we can do group by and take the other things, and we have the layer, and matplotlib. That we occupy 2 or 3 or 4 or 5 layers. Then we start to do that higher layer. So, okay, right. So let's go back to your data. Again, so now we have country, year, sex, age group, right? Age group. These are all partitioning. Okay, what do I mean by partitioning? Let me introduce the word. When I say partition, I mean I create a subdivision that is mutually exclusive and exhaustive. Meaning that you cannot belong to 2 steps, and all the steps add together to find the whole. Nobody gets left out. Okay? So a partition in this room could be, say, here. So that I separate left from the right. You cannot belong to both, either left or right. And there's nothing else. There's only left and right. Now, if I divide into 3 groups, then we have to belong to one. Okay? And nobody belongs to nothing. Right? You have to belong to one group. All the groups add up to it. So that's called partitioning. This is still a partitioning. Male and female are partitioned. Year, age is a partition. What else? What's this? Number of suicides. Now we get to the information. Right? This is the number you want to get at. It's the number of suicides. What's the population? Population is the size of that partition. So a lot of times this is the most basic, the most practical way of looking at data. Okay? You have some kind of partitioning field, population, sex, age, country. I think 4 things, right? Population, sex, age, country, oh, year, right? So you can say, I'm looking at death in 1987, in which case you group by year, but you don't care about country. I'm looking at death by Albania. So you look at countries, you don't care about year. I'm looking at Albania in 1987. Male. See what I mean? And based on that, you get a smaller and smaller population subdivision. And based on that, whatever definition of the partition you end up with, let's say by country and sex. I care about year, I care about age, just country and sex. Then you have something like male Algerian, female Albanian. Okay? Then you have the population, then you have the number of inside, then you have the weight. Yeah, that makes sense? Right. Here's the thing. What have I defined? I have defined what's called target variable with Y. Y is the suicide rate. Right? Y is the suicide rate. Okay? Now, I'm sorry if you guys, I really need to use Blackboard. I can't use this thing anymore. You're guys are nuts. Pen. Okay, what do we have? Country, right? Year, sex, age, right? Okay, and then number of people, and then suicide. So let's call it N and S. Okay, N and S. Right? So this is how it's listed, right? Everybody pay attention. Again, I don't want you to look at your problem. I want you to look at their problem. I think it's yours right now. I'm going to take care of it. Okay? So yours is going to become the focus. Yours is going to become the focus. But right now, focus on their problem. Okay. What exactly did you want to do? You want to predict suicide rate. You want to predict something like S over N. Suicide over number. Yeah, of the next year. Right? Right. So, how do this become your thing? Now, there are two things, okay? If you really want to predict, then that means you want to predict S over N for a given line, correct? So basically, the same year as before, sorry, same country as before, same sex, same age, but year plus 1. Yes? Yes, year plus 1. Yeah? So that if you did this, what kind of problem are you doing? Is it classification, regression? Forecasting. Forecasting is a subset of regression, right? So your output variable is a number. It's not a category. Right? Yeah, so forecasting. If you're forecasting a number, so it's kind of regression. Regressing the number of next year's suicide rate of happening. But you're right. Normally they don't use the word regression, they use time series. Forecast. Yeah, time series forecast. Now, let me do something else. Let's say that, how many lines are there? How many lines are there? Well, here, let's do this. If I group by year, sex, and age. How many partitions do I have? I'll just make the number up. Let's say you have 100 countries. You have 2 sets. Okay? 100 countries times 2, 200. How many age groups do you have? Let's say 5. Okay? 5. 5 times 200 is 1,000. You have 1,000 time series forecast problem. Okay? This is called auto-regressive time series model. Why is it auto-regressive? It's because what you're trying to predict is what you used to predict. You use past suicide to predict future suicide. Okay? For auto-regressive. Auto-predict. Okay? Auto-regressive because you're using past suicide rate to predict future suicide rate. And this is valuable. For this exercise, how many such problems can you do? How many such things can you have? You have 1,000. Because you have 100 countries, 2 sets, and 5 age groups. Yeah, this is called auto-regressive. Alternatively, what if somebody else, and this was somebody else, no, I'm kidding, somebody else. You know, I noticed that old people and young people they have different suicide rates. Okay? So maybe instead of using age, okay, forget it, let's just make it male, female easy. Okay? Instead of making one auto-regressive problem for male and one for female, how about we just do 500 problems, but each problem includes male and female. Yeah. But it's no longer auto-regressive because you're not predicting suicide rate just from the past suicide rate. You predict suicide rate from sex. That's an alternative. See what I mean? Okay. In which case, you actually have 500 different regression equations you do. But for every male and female, you add them together. And then you add the variable male equal to 1, right? Female, you can add variable 0, something like that. Next, you can also say, how about sex and age? So you add another variable, you call sex, call it sex. Let's call this S. This is suicide negative. Okay? S for sex, A for age. Right? You can introduce sex and age. Never mind how you're going to introduce it. It's going to go back to the thing that I've been talking about. Ordinal, ratio scale, so forth. Right? So in that case, it's not just auto-regressive, right? This becomes a panel regression. So if I have y is equal to a1 x1 plus a2 x2, you're using something else, x to predict y. If you want to say yt plus 1 is equal to a1 yt plus a2 yt minus 1, this is auto-predictive. If you have both, then it becomes a panel regression. Okay, let me say that again. If y borrow is regressed from previous y, suicide rate for whatever particular segment is a function of past suicide rate. That's also regressive frequency. Y plus 1 is a function of yt, yt minus 1, yt minus age at all. You can say that y, the suicide rate is a function of sex and age. Then it becomes regression. Ordinary regression is like that, right? Y is a function of x. But if you have this thing where y in the future is a function of a whole bunch of things in the past, not necessarily just itself, then it's all kinds of questions. You, right now, can do a few things, just based on this alone. You can do 1,000 autoregressive problems. You can do, 100 tandem regression, including age and sex, right? Or you can have something else, like what if suicide is a function of the country? In which case, C is another variable, right? You can do that as well. But this is where the reason I want you to pay attention, I want all of you to pay attention to this. It's not obvious. Even if the data is represented in a nice table, it's not obvious what kind of formulation it is. Right? So, my suggestion is we define it all, but you probably want to try to find out what is your sense working through with? You make it also regressive? Should we think that suicide is a function? Now, while you're thinking, let me give you another option. And this is where data scientists start to become worthwhile. Let's say that you have a hypothesis that suicide is a function of where you live. So it's a country, that's a function of country. But certain countries are similar. For example, we can say that certain countries higher developed or more economically developed or richer countries have similar suicide. Asia, in which case we have to do something else. Like take a country name, go to another database that groups country by industrial development, group the country by standard of living, group the country by continent, group the country by whatever, and use that as your variable. Okay? To become your variable. But in other words, instead of having suicide as a function of sex, age, and country, it is suicide, age, and how rich that country is. Or whether or not it is Asian country. Maybe Asian country has two viewpoints. You see what I mean? This is so that's the data point, that's the data software. No. This is what it looks like with the project. It is a homework in self-contained, right? I give you this page to go run a regression. That's what you would have done last year. Okay? Last year I would have given you this and you run a regression. This year, this is just the beginning. Nothing into the problem. Right? You see what I mean? It looks like things spin out of control, but it gets bigger, but yeah. Okay? So you have to think to yourself, and this is what we mean by problem formulation. Start thinking about data, start thinking about what you're going to use with Y, X. Are you going to use this as a definition of cohort and do different auto-regression, or you're going to do tandem regression and use that as your variable? Right? Does that make any sense? Okay, if it doesn't make sense, first time to think about it. Okay? So, again, this is not a homework. So you don't get one data set, run through something, and get a result. You have to think about what you want to do. Now I'm pretending to be you. I'm thinking on your behalf. I'm thinking out loud. Okay? What do you think? So, tell me, what do you think? You have a feeling that suicide is a function of development. If your hypothesis is richer countries have higher suicide rate. Okay? Or middle income level. So I don't know, maybe poor people poor countries don't really have high suicide rate because they die a lot already just from bad health. You see what I mean? what else can you do? You can actually look up that rate from something else. Further, yeah, maybe there's something about the higher country with higher murder rate may have a smaller suicide rate. So start thinking about this. Start thinking about it. Now, the shortcut to thinking about this is what? You see how yeah? The shortcut, but this is not the real shortcut, this is the way people do things. You would look up not this, you would Google how do you model suicide, right? So you would look up something like suicide prediction model. And this will show up 500 pages. You look at the P1, what does it do? Oh, most of the papers don't use auto predictive because it doesn't mean anything. They use sex as a factor, they use age as a factor, they use economic development of the country as a factor. Then it will make more sense. You're not the first person thinking about trying to predict suicide. Right? But maybe there's something about your application that has to be done. For example, it has to cover Thailand. Okay? Or it covers Thailand, but it doesn't separate sex. And I want to know what's born versus here. Okay? Then you start to think about that. Okay? So what's the name of this team, by the way? Nominal. Okay. So this would be just on the fact that you want to look at the suicide data. Just that. Think of it. Yeah. If you were really my team, I would say you should have thought of it, right? You should ask yourself this. Yeah. What exactly you want to predict? What is what? Yeah. Is sex to you a factor, or is sex to you something that you just want to separate? I'm just going to create one model for boy, one model for girl. One model for young people, one model for old people. But you're all young and old, that really has something. Yeah? Maybe it's linear. Maybe it's not. Maybe you have a high suicide rate at Ph.D. and drop down and start looking and then become old and worldly, you have high suicide rate. Maybe that happens in the developed country, but maybe in a poor country, it's the other way around. Young people don't care, they're free. People who work hard, suffer, they kill themselves. When they're old, they even want respect, they must do themselves like that. So maybe the curve is different. What is the reason? Now, this is slightly old-fashioned in the sense that you have to start thinking of a thesis first, of a hypothesis. In data analytics, the modern way of doing data analytics, you will try to run a lot of unsupervised learning algorithms to come up with patterns. Okay? But this, I'm going old-fashioned with you guys. Like think old-fashioned. So you have to think about what is the X to predict Y. Okay? But the more and more modern way of doing data science is something like, look at it, and let's see if you can find some kind of a natural cluster. Maybe cluster by country, cluster by age. I don't know. See what happens. Okay, but that's a little bit harder. That's a little bit harder. So just get your idea that regression has maybe formulation. Okay, that's already a challenge for okay. Now, you said you had a few ideas. What else?
We need to create any factors of.
Okay. You have to ask yourself, with the crisis that was from your book, do you think that Thailand has 1,000 of economic PhDs? Yeah. If you Google, you're going to find hundreds of papers. Have you decided to read them? Okay. Right? Literature survey is a very important part of the methodology. You know that first block about building tools? Okay? You have to look at the tools that have been used previously to solve. Same with the experimentation. You have to look at previous experimentation. There we go. Same with the conclusion. You have to say, what is your conclusion? Is it different from other people's conclusion? Okay. So, my bet, I can bet my entire life on the fact that the question is asked. You were not the first one to ask. Okay? So there may be 2,000 PhD students who ask this question. What did they come with? What would you like to do differently? How can you update the study? Yeah. So it's good to have something that you're interested in. But it's also good to say, well, you are not reinventing the wheel. Right? So maybe I should give as a homework, not just this as a homework. Each team do some kind of listener survey, listener review. Like, what have people done similarly in this kind of approach? Okay? Now, team of 5 will come up with at least 5 papers. Team of 4 will come up with at least 4 papers, and each of you will at least be responsible for 1 paper. Right? So, every single one, homework for Monday is to find a paper that is a precursor of what you are thinking of doing. Make sure it's not the same one as you read. Okay? And I guarantee you, I look at the sort of type of problem you pose. It's not, you're not going to find this 5. Each of these problems has 5 things. And pick one that I think you can manage to talk about. You can discuss. So you can look at it. It's not too technically difficult. Okay? So pick one that's relevant to your project, that you think is reasonably simple to understand. Okay? So again, this is where you can have a big team and small team. If you have big team, you have to have 5 papers. If you have small team, yeah. Now, I would guess the suicide problem is a bit more interesting. If anything, we don't have 500 PhD studying what happened after the COVID school. Let's do that. Okay, so think about it. What else? That's it. Okay. Very good. No, okay, you next. Or who wants to go next? Right? So everybody gets that, right? It looks like they want to do regression, in particular forecast. But forecast what? Based on what? Okay? Because based on this class, suicide rate, or some other factors like country and so forth. Okay, think about that. So we'll look at that. Suicide rate prediction. National suicide rate prediction. Here's a good tip. When you Google, you put in the word PDF. Chances are you will find it as a word to this. Okay, go.
Okay, so we think that there are both people. What they were about using I think
Best 11 players. Okay, fine. Now, have you been looking around for previous records?
not yet, not like
That's it, okay? What have you kind of come up with? Share, I want you to share. I want you to just share. By the way, before this thing gets erased, you see that this page is very nice. It already does the histogram for you. That's what I mean by visualization, right? The first thing you want to know is how is the data distributed. And on top of this, there's already a histogram. I'm not surprised that the suicide rate has this shape. A lot of distributions will have this shape because the top is above 0. Good. Complete. No. That.
So there will be that few of data.
Okay. Are these 5 layers or from FIFA? Okay, good. So this is compiled by FIFA, right? And short name, long name, okay, what else? Age, date of birth, height, weight, nationality, what's overall? Score? Okay. What's the potential? Okay. What's value? Yes, against value of that contract, right? Yeah. Their wage, player position, okay, fine. We put international reputation, we put. Okay, good. Okay. Player tab, good. That's very good as well. Yeah, between position. What's the difference between position and the previous thing? That was yeah, there was something before that about position. Okay, sorry. Body type. Oh, there's actually a body type. Name up there, right? Join, New Jersey, online, loan from, contract value, location, position. Okay, so they can play different position with their clocks, right? Okay. CK driving and that. And this is all scoring. Oh, right. Depending, physicality, dribbling, passing, shooting. Okay, good. Now, this is working off data that's already, in a way, processed, in the sense that you already get the score, right? You're not really doing it. You kind of get the score. Okay. Now, let me backtrack you a little bit. Before you get to machine learning, just to say, open your mind, maybe visualization, maybe some kind of a database finding or something like that. What exactly do you think you can do with this? When you say you want to pick the best, all right? Okay. Well, software is a team sport, yes? So, is individual scoring, do they take into account their contribution to the team, or is it like personal ability? Okay. Other scores as well. Good. Okay. So, if you're talking about, again, let's try to figure out. You want to pick, you literally want to pick that team. Okay? Now, my question is there any kind of constraint to this? Because already the best team would be like all star, right? We have all star. The all star doesn't necessarily play together well, but certainly it's a solved problem. You want to do an all star to say whoever score highest in this category or right? Who's the best goalie, who's the best wing, whoever, right and left, and you just add them all up. Good, that's good. Okay. You should have a limited budget. Yeah, that's interesting. That's interesting. That's interesting. Okay, so we have a limited budget. Now, if you look over here, something very handy. Remember the nice picture that I drew? You're going to do focusing on that. Yours is over here. Right, everybody look up. Pay attention to don't pay attention to your project. Look at their project. The picture that I draw and I plan to spend most of my lecture time is around this forecast. Okay? It's DA that based on model built by machine learning, kind of AI type thing. So this is the loop that I'm looking for. But I did mention that yeah, there are other aspects. For example, the big data technology we didn't talk about, the fact that you can have statistical models, you can have optimization. Europe is here. Okay? Get that? So, in my opinion, it's not exactly machine learning problem. Okay? Reinforcement learning does the optimization, but it's totally optimal control. Not this kind of bad optimization. This is more like if you have a limited budget, what box you buy on the data, so that you optimize the data, you make it microwave by the what a portfolio problem. Right? So, if you are going to do this, I'm very happy to do this. Okay? My first love is optimization. My second love is machine learning. So, I love both. Okay? I'm focusing my class on machine learning. That's the context we live in today. So, if you want to do optimization, I'm very happy with that. Bear in mind that it's going to make you fight away from machine learning. If you committed that, then you. Okay? Now let's start to think about that. It's a long story. Let me talk about optimization. So let me actually cut short PhD. Oh, we have that. But I don't want you to go away because of the okay. Come on, idea. I don't know.
Maybe we focus on one thing. We see that it's facing the other.
What players did put in? So they have a roster of players. That's good. This is very interesting. Yeah. Now this, you guys hear that? Yes, I want you to pay attention 100% on their problem, not your problem. Instead of building the perfect team, given a limited budget, they want to say, I have a team. I have a roster of players, right? And I'm facing this team with this roster. Let's just say, for simplicity's sake, we do an air plan. What are you going to put down? Yeah? You're going to put this guy who's a right footer who's very good at long passes, another is dribbling, dribbling. Yeah? This is an extremely difficult problem. Very good. You can think of it both ways. You can think of having enough historical match data. You can kind of learn the best outcome. Okay? So yeah, it looks obvious that if they have a long passer, we have a dribbler, but a dribbler not that good at countering the long pass. So we need to take the long pass there as well, but we try to do something else. So it becomes a learning problem. But if you're thinking about matching criteria or criteria, then it becomes more like optimization. Okay. My guess is it's going to be more interesting as a machine learning. Okay. So So it could be something like you can learn different profiles. You can add the profile together. You set some kind of a sheet profile. If I have a sheet profile based on individual players, you know, because have you guys seen a top web? Have you seen what top web looks like? Top web looks like this. When you have say let's say 5 criteria, okay? Right. We have 5 criteria, and maybe one team is good at this, but weak at that, okay? And then you can say something like, if the other team is like this, chances are we'll beat them if we say a team that looks like this. You see what I mean? It's sort of like competing conflict. Yeah? So that would be a very interesting problem. And that's something that can be learned. Because you can say, roughly speaking, you know, 9 out of 10 times, whenever they give this kind of conflict, we with them in this conflict, we beat them. Okay? But if they go with the other thing, maybe we should be generalists. So yeah, I think it's very good. I think it's very interesting problem. The reason I didn't want to go so far into optimization is because optimization is a huge field. Such a huge field that before you even get started, it's a lot of work. Okay, what else? Okay, that'll be like the graph theory that I mentioned there. Okay, but I like the second one. Let's think about it. Now, guys, there are obsessed with football, but this is what I really got to have. This is something that I always have, and kind of like my style. Yes, you say my gift or my style. We always have to start with the problem. What exactly they have may be well studied under different rules, like the liquid campaign. Yeah? The liquid campaign has a similar kind of thing. You can have a formation that's very mobile, but uses small cannon, versus, you know, not very mobile, big cannon. Strong on the defense, strong on the offense, strong in the open terrain, or able to do in mountain terrain. And based on this, also have history, world history. Okay? So if you want to exactly look for survey problems, when I say you use this survey, one, start with football. Okay? Maybe you have football as a key word, but if you something like strategic, counter, offense, something like that, you might find something else. It may show up in something like mental practice. Okay? How do you counteract the syndrome? This syndrome attacks your immunity. This syndrome makes you weak in general, lose appetite. So all you have to do is just make it quick and you're going to eat a lot, become nutritious, and then find out the disease themselves. See what I mean? So this is the abstraction I want you to have with thing to. Just because your problem is not with football, doesn't mean it has to be, and in fact, this is how operational research is about. Okay? There is nobody who didn't want to work on way that way in World War II. There's no way that they work. But we use this kind of optimization to that. And we will have this kind of aspect. Very good project, not the very good. My purpose would be. What am I doing by moving? It's very hard. That is really difficult. Okay. Okay, very good. Oh, you all very good. So we only have 3 teams. Go ahead and do the rest. I'm asking. I'm not on the 2, right? Oh, yeah. What happens to the rest?
will say, oh, it's not like that. So,
yeah. Okay, we talked about that. What do you use this market?
Right now, we are trying to simplify how to download the photo by using
Okay. Yeah, okay, good. How do you do the program? You haven't yet. Okay. Well, I can't help you very much with the Python. I don't really I can use this side. Yeah, sure. No, this is just harvesting, right? Downloading, not yeah. First of all, once you get the picture, remember, look up things like all the captions. Yeah. I don't almost read my mind on it, right? Yeah, originally I said, look at all of them generated. I think that the interpreter needs to use all of that. Yeah. So that's something that there. I see a lot of software that's okay, not free, but I think you will be able to find okay. Okay, no, we go. You did that. Let's do that right now. Go to paper with code. Okay, this is very good because it's it gives you a methodology, but it also gives you the code, which is mostly Python, I think. Picture, auto caption, picture. Video, nope, we don't want video. I thought caption was going to be something that's, yeah, auto encoding scene graph for image captioning, RNN for caption generation, reconstructing paths with the person. Video, no, that's not. I think this paper might be useful. Auto encoding scene graph for image captioning, right? This looks promising. Oops. Yeah, this looks interesting. Can you guys see that? Auto encoding scene graph for image captioning. Scene graph. And this takes a convolutional neural network and try to learn some. This looks interesting. Yeah, I think you find something in here or in the reference. By the way, don't just read the paper, always read the reference. Every time I read one paper, I end up downloading 2 or 3 more paper from the reference. Okay? So I think this is good. It's something along this line might be useful. And just to give you a glimpse of what sort of thing it does. Okay? Motorbike, park, road, dirty. Okay, so that's good. So it is a graph in the sense that it has kind of grammar, right? Patan Kriya Kam, who's doing what to what. Okay? Elephant is in the tree.
Elephant in the tree. Elephant in the tree. More elephants in the tree. Yeah, so something like this. I think this is something that's it's more your thing. Car on road, bus on road. Huh? So very interesting.
Okay. So you might think of that. Now, what you have to do is this. Remember I told you that object recognition is easy. Action is difficult because it has a relationship. So your fallback position is to go back to just basically what you did. Right? So in other words, you have a woman holding a product. Okay? The best information would be a woman holding a product. But if you don't have to, you can't get that far. You can just do woman plus product. Okay? So it's not like this thing where you have this crowd. Elephant in tree. This elephant tree. Okay? You do that. Okay? So don't get hung up on having to have this relationship, this kind of stuff. You can, great. Search it, and then write down the goal. Not quite global at the moment. We'll just do flexible words. Okay? So it becomes a little bit more frequent. Remember I told you about data mining, about basket? Well, you can think of a picture as a basket. And a basket contains two elements. Basket contains one person, one woman, one product. One woman, one child, two products. Okay? So then you can do that. So read that and you can do it. Yeah, once you get to the experiment, you get the results, then you discuss it. Yeah, 1, 2, 3, 4, 5. Data, preparation, methodology, experimentation, conclusion. You need the deliverable. Yeah, you present the software as well. Okay? Software database. The data is not that big. The whole project is like, okay, in the final handout, it will be like, I'm the one using the result. So, like I take this project. What are you going to do? You're going to keep defining you are going to keep the executable code. You're going to give you the data source, blah, 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 and this is it. For my own market. Go look at the paper we wrote. That's a very good format. Okay. Always, the introduction will have kind of a problem statement, we have kind of a related word, final word, yeah. Discussion of data source, so forth. The methodology part. Now, in the paper, the data preparation and methodology will sometimes become together. It's not like a separate section of data, separate section of methodology, sometimes together. Right? The experimentation and the proof. Yeah, 1, 2, 3, 4, 5. It will look big like that. Okay, that is I do 5 blocks. The data itself, what to do with it? Yeah, no, but for the paper, the data and data preparation, they need the same section. But you have another section, really help in production. Okay. Okay. Now, you guys already get points for doing this. Now, what about the other team? They have to say something. Otherwise, they go. Okay, we will have to let somebody line it because it doesn't say something quick or we get nothing. With all the situation out there, you just stay home if you're afraid to come in, but not without you like coming in. That's
ครับ
Okay, guys. What kind of model can we think about, right? Let's go. You share your thing again. Okay.